part of a team that's actually conducting a systematic review of evidence on educational interventions in the U.S. Department of Education's WWC, What Works Clearinghouse, which I've been looking at with a lot of interest because we're trying to do similar things. And you also provide technical assistance and evaluation to state child welfare agencies, developing and implementing a number of programs for youth, for the vulnerable. Brian Gill is a senior fellow at Mathematica Policy Research based in Cambridge. Now you converge from all your different locations here, which is really lovely. And you focus on K-12 education policy, but mostly domestic, you said. You've done extensive research on measures of school and educator performance, charter schools, and the implementation and impacts of high-stakes testing and other accountability regimes. You've actually helped to develop and test measures of effectiveness of educators. And you've played a pioneering role in the studies on evaluation of school principals and teachers. Gil is one of the nation's leading experts on the effects of charter schools. And we'll have you back for another talk on that, I guess.
Great, happy to do that.
And we're certainly getting a lot of interest from Brazil and other countries, and I'm sure across every other globe. And has led several key studies, including the first rigorous nationwide evaluations of nonprofit charter school management organizations and of the KIPP schools. Audrey, who before this life helped us a lot in LAC. She worked very closely with Barbara when we did a lot of the Stallings data collection and Stallings work in several of our countries, both for the Great Teachers book, but also afterwards in response to demands from many countries. But of course now you've moved, you're a senior researcher at the Mathematica Policy Research, and you're in the International Development Division, or you focus on international development. You have more than 15 years of experience on international research, particularly in the areas of school effectiveness, opportunity to learn, early grade assessments, evaluation of complementary education system, cost-benefit and cost-effectiveness analysis in secondary education. You're currently part of a team assessing the impact of reading interventions across Latin America and the Caribbean, and I'd love to get a separate conversation on that. You have provided a lot of technical assistance to ministries of education and so on. I'm going to pronounce it right. Mahjabeen. No, I can do it. Mahjabeen Raza is going to be our discussant today, and she is actually a researcher and a project co-director of TIPS, which is a low and middle income countries focused systematic classroom observation instrument that connects classroom practices and processes to students' academic and socio-emotional outcomes. And I think one of the most important things that you need to know about her is that we have grabbed her, Ezekiel has grabbed her to be a part of the working group that you must be aware of, that is working on an instrument for us to be as part of the SDI or the revamped
service delivery instrument.
Service delivery instrument, the revamped service delivery instrument that sort of takes some of the areas that were in sub-air, but tries to get more into implementation, piggybacking off of the service delivery instrument that we used to have, and classroom observation is a key module in that, as is school principals, managerial effectiveness, right? So with that, actually I spend more time talking about his project, but welcome. You're at New York University right now, and you're also doing work in Uganda and India. So with that, over to you, and let's say we have about till about 20 or 25 after 1.
No problem.
Yeah.
So thank you so much for having us here today. We're really delighted to be here to present to you some findings from one of our recent studies that looked at the measurement of teacher practices and behavior, in which we examined 5 widely used observation instruments. Before I get started, I want to just briefly acknowledge some of the contributors to the report on which this presentation will be based. That includes our funder, the Regional Educational Laboratory Mid-Atlantic, as well as our co-authors, Thomas Cohen and Kate Place, who are not here with us today but collaborated on the report. Brian and I are co-authors on the report, and Audrey will also be providing some insights for us today on our findings. So our planned agenda for today's presentation, I'll start by describing the motivation and the aims of our study. I'll then summarize our research methods and our main findings for each of 3 examinations that we conducted in the study. So the first examination looked at the content of instruments, and by that we mean what specific instructional practices do each of the instruments measure. The second examination looked at the predictive power of different observation scores for student learning. And our third examination explored potential bias of different observation scores based on classroom characteristics. And then we'll end with a discussion of those findings. I'll discuss implications for U.S. education policy and practice, and then Audrey will step in and discuss implications for international work, drawing on insights from her experiences working with classroom observations in various countries. And as Rima said, please feel free to interrupt with clarifying questions, even if they're only semi-burning, that is okay.
Darn.
So the motivation for our study comes out of the current need for evidence to inform the selection and use of observation instruments. So as I'm sure all of you are aware, many education agencies are considering adopting commercially available observation instruments for use in their evaluation systems. And these instruments are also becoming increasingly popular for use in research studies to derive measures of teacher practice. And yet there's little data that's available to help choose from among existing instruments. There's also little information about which specific dimensions of instructional practice might warrant greatest emphasis for evaluating teachers or for identifying professional development priorities. And there's been little attention paid to the fairness of observation instruments for evaluating teachers. So we sought out to address these gaps and to inform decisions around the selection and use of observation instruments by conducting a comparison of 5 widely used observation instruments, which are shown on this slide. We focused on their application for assessing instruction in English, language arts, and math. And of the 5 instruments, 2 of them, the Classroom Assessment Scoring System, or the CLASS, and the Framework for Teaching, or the FFT, are designed for use in both English language arts and math classes. The Protocol for Language Arts Teaching Observations, or the PLATO, is designed for use specifically in English language arts. And then the other 2 instruments we looked at, the Mathematical Quality of Instruction and the UTeach Observation Protocol, or the MQI, and the UTOP, are applicable only to the math classes. The UTOP actually can be used to assess science instruction as well, but in our study we focused specifically on English language arts and math instruction. And these 5 instruments are all commercially available. They've all been widely used in the US, and they all share some characteristics in their general structure. So all 5 instruments are designed to measure teacher instructional practices in various areas of instruction, typically called domains. So each instrument measures 3 to 5 different domains of instruction. They all also use quality rating systems to assign scores. So they range from 1 to 4 up to 1 to 7, and assign scores based on the assessment of, for example, high, medium, or low performance on a given instructional practice, or on the presence or absence of a desired or undesirable instructional practice. All of the instruments also assign scores on various subscores. So they range in including, I think, 12 or it might be 13 up to 30 subscores per instrument. And then those are combined to create an overall score. And for some of the instruments, they're also designed to combine subsets of the subscores into domain scores. So to conduct our examination, we use data from the Measures of Effective Teaching project, or the MET project, and I've heard that many of you are familiar with this project, but I will just give you a brief overview in case any of you are trying to remember what that project was. So this is a Bill and Melinda Gates Foundation project. It was implemented by a research partnership including dozens of independent research teams, and they collected teacher quality data on about 3,000 volunteer teachers who were instructing grades 4 through 9 They were all instructing at about 300 schools across the U.S. in 6 large urban school districts. Each school district was in a different state, so the states included North Carolina, Texas, Colorado, Florida, Tennessee, and New York. And the MET project followed teachers for up to 3 years, but in our study, we focus only on the first 2 years, the 2009-10 and the 2010-11 school years, because those are the years for which there were publicly available data at this time. For those of you familiar with the MET project, you probably know that one of the unique characteristics of this project is that they collected a trove of different types of teacher effectiveness data. In our study, we focus on 2 main data sources from the MET project. The first is teachers' classroom observation scores, and the way that MET derived these was that they video recorded lessons on 2 to 4 days per year per teacher, and then those video recordings were scored by trained and certified raters working for the research project, and they were scored using multiple observation instruments, including the 5 that we focus on here. So in other words, for a given teacher's lesson, we're able to get observation scores from multiple instruments. So this provides a unique opportunity to make comparisons across the instruments. All of the instruments were scored in both years of the study that we look at, except for one, which is the U-top, and that instrument was only used in the first year of the study, so we only have information on a subsample of teachers. The other type of data we use for MET is data on student and classroom background characteristics and outcomes. For educational outcomes, we look at standardized achievement test scores in math and English language arts, and we look at those at the student and classroom level. We also use data on demographic information such as student gender or race and ethnicity at the student and the classroom levels. So the purpose of our study was to address 3 specific research questions. The first was, what are the major differences and similarities in the dimensions of instruction that are rated by the 5 observation instruments? The second was, are observation scores in some dimensions of instruction more strongly and consistently related to teachers' value-added scores than other dimensions? And third, how do characteristics of students in a teacher's classroom affect observation ratings? So for the bulk of the remainder of the presentation, what I'm planning to do is to walk through each of these research questions in turn, and I'll describe some details about our analytic approach to answering the questions and then summarize the main findings for each. But before I do that, I want to preview the findings to give you a sense of where we're headed. So our analysis yielded 3 main findings. The first is that large parts of the 5 instruments are conceptually consistent in terms of the dimensions of instruction that they measure, but they do differ in how comprehensively they measure each dimension. Second, we found that observation scores for all of the examined dimensions were modestly related to teachers' value-added scores, but of the dimensions that we had data on, the classroom management dimension stood out as being most strongly and consistently related. And third, we found that characteristics of students in the classroom do affect observation scores for some instruments, but this was true in English language arts classes and not in math classes. So our first research question, what are the differences and similarities in the dimensions of instruction rated by the 5 observation instruments? So this research question addresses a need for comparative information about the content of different existing instruments. So while there is substantial availability of information on teaching practices that are measured in any given rubric, including the 5 rubrics that we focus on in this study, there's little readily available information about differences and similarities in the content of the different instruments. And that type of comparative information could be important for helping education agencies and researchers figure out which of the available existing instruments is most aligned to their needs. So to address this need and to answer our first research question, we analyzed the dimensions of instruction that are measured in the 5 observation instruments. And we did this by conducting a content analysis of the rubrics themselves. So we focused on the 5 rubrics, the class, FFT, the Plato, the MQI, and the UTOP. And we did qualitative coding of individual items, meaning text on specific teacher practices in each instrument, in order to identify common thematic groupings across the instruments. And we call those common groupings dimensions of instruction. The dimensions that we identify are not identical to the domains identified by instrument developers. So as I mentioned before, all of these instruments are structured in a way where they're designed to measure teaching practices in various domains. However, we weren't able to directly compare domains across the instruments for a couple of reasons. One is because the instruments differ in terms of the level of detail that they use to define the domains. And another is that they sometimes differ in how they organize overlapping subdomains into higher level categories. So basically, if we use the domains and subdomains identified by the instrument developers, it doesn't provide an apples-to-apples comparison. So rather than take that approach, we use an inductive approach to code bottom-up from these individual items in the instruments in order to get to the common groupings. And our content analysis identified 10 dimensions of instruction across the 5 examined instruments. 8 of those 10 dimensions were common across all 5 instruments. So all 5 of these instruments measured supportive learning environment, student focus, classroom management, student intellectual engagement with content, lesson structure and facilitation, teachers' content understanding, language and discourse, and feedback and assessment. And only 2 of the dimensions we identified, the active student participation in class activities and teacher professionalism, were measured in some but not all of the 5 instruments. So this demonstrates that the large parts of the various instruments are conceptually consistent. But at the same time, we also found that instruments differed in how comprehensively they measure each dimension of instruction. We assessed the comprehensiveness of a measure in terms of how many different subdimensions an instrument measures for a given dimension. So as an example, for the language and discourse dimension that we identified, our content analysis revealed 3 different subdimensions that instruments measure. These were in-depth content-driven discussion, use of academic language, and discussion facilitation and cumulative exchanges. And we also found that all of the 5 instruments included measures of language and discourse. But what you can see here is that the instruments differed in how many different subdimensions they were looking at for that measure. So 2 of them, the FFT and the UTOP, each measured just 1 subdimension. The class and the MQI each measured 2 different subdimensions, and the Plato was the only instrument that measured all 3 of the subdimensions. So while we would conclude that all 5 instruments measure language and discourse to some extent, the Plato instrument provides the most comprehensive measure of language and discourse. So of the 10 total dimensions we identified, on average across those dimensions, instruments measured 57 to 75% of the subdimensions. And of the 5 instruments, we found that the Plato instrument tended to exhibit the best coverage of the subdimension. So it was most consistently measuring the most subdimensions. And the Plato actually measured the highest percentage of subdimensions for 7 of the 10 dimensions. So our second research question was whether observation scores in some dimensions of instruction are more strongly and consistently related to teachers' value-added scores than other dimensions. And this question addresses the current lack of knowledge about observation subscores for different dimensions of instruction and how they're related to student learning. So most examinations of the relationship between observation scores and student learning have focused on the overall score or the total score for an instrument, which is typically calculated as the average of all the subscores on an instrument. And while the overall scores for all 5 of the instruments that we looked at in this study have been found in prior research to be modestly but significantly correlated with value-added scores, it's unclear whether that relationship varies for different dimensions of instructional practice. So for example, for language and discourse scores versus for classroom management scores. And that information could inform whether there are particular dimensions of instruction that might warrant more emphasis for evaluating teachers or for research outcomes. So to address this gap and answer our second question, we analyzed observation dimension scores relationship to student learning. And we did this using data from the MET project on teachers and students who were in grades 4 through 9 for about 1,400 English language arts classrooms and about 1,300 math classrooms. And we conducted a correlation analysis between observation dimension scores and a measure of student learning. Our measure of student learning was teachers' value-added scores. A value-added score is a teacher's estimated impact on student achievement after accounting for other student factors, including their prior achievement and demographic characteristics. And we estimated their value-added scores using student scores on state-administered standardized tests in English language arts and math, and using fixed effects models. And then we correlated those value-added scores with teachers' observation dimension scores for 7 dimensions that had scores from at least 2 instruments in the metadata. And we wanted to examine both the strength of a dimension scores relationship to value added as well as the consistency of those relationships. So we constructed 2 types of dimension scores in order to do those analyses. The first type was in order to assess the overall strength of the relationship between a dimension and value added, and we constructed for that a cross-instrument average dimension score. So for example, for the classroom management dimension, what we did is we took the classroom management score for all instruments that had them, like the class and the FFT and the UTOP. We standardized them and then we averaged them together in order to get a cross-instrument average score, an overall classroom management score. The second analysis that we did, we looked at the consistency of the relationship between dimension scores and value-added scores. And for that, we constructed instrument-specific dimension scores. So in that case, for classroom management, a teacher would get a classroom management score for each instrument that had one. So they would have a classroom management score and an FFT, classroom management score, and so on. In terms of the strength of the relationships, we found that the observation scores for all 7 of the dimensions were related to teachers' value-added scores. And this slide is showing you the correlations between them. And you can see that for all dimensions, the correlations are modest, but they were all statistically significant. The magnitude of these effects is roughly comparable to what's been found in previous studies that are looking at the relationship between value added and the overall score for the instruments we looked at. Those tend to range from about 0.1 to 0.3, and they're usually around about 0.2. Of the 7 dimensions, classroom management dimension scores had the strongest correlation, but as you can see, the differences among the magnitudes are fairly modest, and we don't know if these are statistically different in size. In terms of consistency, classroom management dimension scores were also more consistently correlated than other scores. So here we're looking at the percentage of significant correlations when looking at those instrument-specific dimension scores. And again, for all 7 of the dimensions, we saw statistically significant results more often than would be expected by chance. But the value-added scores were most consistently correlated for the classroom management dimension and for the feedback and assessment dimension. So when we take those 2 sets of results together for the strength and the consistency, we conclude that classroom management dimension scores stand out as being most strongly and consistently correlated with teachers' value added. However, it's important to keep in mind that this doesn't necessarily mean that classroom management is the most important dimension for student learning. So one possibility is that classroom management practices are actually more consequential for student learning than practices in other dimensions. So that might be the case, for example, if classroom management is a foundational skill that's necessary to be in place before learning in the classroom can occur. But it's also possible that classroom management practices are easier to measure and observe than practices in other dimensions. So if, for example, classroom management measures tend to be less noisy than measures for other dimensions, or if classroom management measures do a better job at discriminating between lower and higher quality teaching practices than other dimensions, then the stronger, more consistent correlations we see in our analysis could be an artifact of those measurement properties and not actually suggest that classroom management matters more for student learning. Now, our analyses can't arbitrate between these 2 possibilities, although in some follow-up work we're doing for the Institute of Education Sciences, we're looking into this a bit more by estimating relationships between dimension scores and value added simultaneously for the different dimension scores, and using a structural equation modeling framework, which allows us to control for differences in measurement error across the different dimension scores. So stay tuned for those results. Our third research question was, how do the characteristics of students in a teacher's classroom affect observation ratings? And this question addresses the current need for information on possible bias in observation instruments, because while the fairness of value-added models for teacher evaluation has been studied extensively, comparatively little attention has been paid to whether observation scores are influenced by characteristics of the classroom. So this could be problematic if, for example, teachers are being rated in part on the students they're assigned to teach and not just on the actual practices that they're implementing. A few studies have found observation scores are correlated with student characteristics, such as the percentage of non-white students or low-income students in a classroom. However, the methods that they've used leave it so that it's unclear whether this is a classroom composition effect, meaning that being assigned a classroom with students of certain traits actually could inflate or deflate a teacher's observation ratings, or it could reflect the inequitable distribution of effective teachers. So that would be if more effective teachers tend to get assigned to teach students with particular characteristics. So in order to shed light in this area, we analyzed observation scores' sensitivity to characteristics of students in the classroom. And we build on prior research by conducting a causal analysis of effects of student characteristics on observation scores by leveraging the fact that the MET project randomly assigned teachers to student classroom groups in the second year of the study. So we used data here on a subsample of about 660 teachers who were randomly assigned in that second year. And we look at observation scores for the 4 instruments that were available in the second year of the study. So that's all the instruments except for UTOP, because recall that was only used in the first year of the study. And in this analysis, we look both at instruments' overall scores, so that total score, the average of all the subscores, as well as their dimension scores in the way that we looked at in the second part of the analysis. And we look at the relationship between a given observation score and a classroom characteristic measure by regressing an observation score on the classroom characteristic, and we controlled for randomization blocks. And then we cycled through 4 different classroom characteristics of interest. So we looked at the percentage of non-white students in a classroom, the average prior year achievement in English language arts, the average prior year achievement in math, and the percentage of students in the classroom who were eligible for the federal school lunch program.
And again, given randomization, all those should be equal across the population of teachers, right?
So that's a really great question, and actually the answer is no. Because consider, if they were going to be equal, it wouldn't allow us to actually look at how differences in the composition of classrooms affect observation ratings. But the unique thing about the MET design is what they did is they created groups of students, like a classroom of students, and then they randomly assigned those classrooms to teachers. So in this case, the relationship between what kind of teacher gets matched to what kind of student should be random, but who's actually in the classroom is going to differ across classrooms.
They allowed the schools to use their usual practices of grouping kids together and then randomly assign to the groups in essence.
So we found that characteristics of the students in the classroom do affect observation scores. So overall, we saw statistically significant results for about 12% of the 156 total regressions that we looked at. So this is about twice the rate that you would expect to see by chance. And we saw statistically significant results beyond chance expectations in English language arts classrooms, but not in math classrooms. So you can see in math classrooms, they were only significant about 4% of the time. And for 2 of the 4 characteristics of classrooms that we examined, so we saw significant results beyond what would be expected by chance when looking at the effects of the percentage of non-white students in a classroom and the average prior year English language arts score, but not the other 2 measures. We found that those characteristics of students in English language arts classrooms reduce scores on the FFT and the class instruments, but not on the Plato instrument. And recall that those are the 3 instruments that were used to assess English language arts instruction in the MET project. So more specifically, we found that having more non-white students in the classroom reduced scores on both the FFT and class, and having more lower achieving students in the classroom reduced FFT scores over the class scores. And to give you a sense of the magnitude of these relationships, we estimated that on average, an increase of 25 percentage points in the share of non-white students reduces a median English language arts teacher's overall observation score by 5 to 7 percentile points. So in this analysis, we find that characteristics of students in English language arts classrooms do affect observation scores. However, there is more than one way that characteristics of students in the classroom might affect scores, and that's important to keep in mind. So one possibility is that instruments are systematically biased against teachers of non-white and lower achieving students in English language arts. So this could be the case, for example, if different types of students have different types of instructional needs, and teachers are appropriately altering their instruction in order to meet those different types of needs, but the instruments are not sensitive to those different needs, and so they unfairly give teachers lower scores because they're altering their instruction. Another possibility, though, is that teachers are actually less effective when teaching non-white and lower achieving students. So this could be the case if teachers are inappropriately altering their instruction for different types of students. So for example, teachers might be subject to implicit biases that cause them to lower their expectations of non-white or lower achieving students, which is a pattern that research has suggested occurs. And if that's the case, that might cause teachers to actually change their practices to less effective practices, which is then reflected in the instrument scores. But if this is the source of the relationship that we see, that would reflect a teaching problem and not a systematic bias, a rater bias in the instruments.
Excuse me, quick clarification. Is the possibility that the teachers are teaching the same way it's perceived differently by the raters in one of these? Because you're saying the first one you explained is changing teaching practices and that being incorrectly observed. But do you have the possibility that they're doing exactly the same thing and being perceived by the raters differently in one of these two?
Yeah, that's a great second example that would apply to the first bullet. So it's another way that the instruments could be systematically biased is if the raters are interpreting the same practices incorrectly.
Same practices, okay. Thank you.
But it's worth noting that not all of the instruments are showing bias, suggesting bias, and it's the same raters.
Same
So
So it was the same raters for all of the instruments. They used the videos and they used the rubric, the different rubrics, and did the ratings.
Almost.
Same set of raters. Almost. Okay.
So it's a very complex design. So for the class instrument, there were a subset of videos that they scored in the first year with one set of ratings. But then later, they came back and they scored the instruments with the FFT, the Plato, and the MQI, and that was done by the same rater.
Nice.
There were some instances where they also had 2 different raters rate so that they could assess inter-rater reliability, but that was a subset of them. And then the UTOP was done separately by a separate set of raters on a subsample.
I have a question. Did you try to see the impact of other characteristics on the instruments?
Gender.
One explanation is that just the level of sensitivity of the instruments is very different. So it's nothing related to the bias or the way how the teacher is conducting the classes, just different sensitivity of the instrument.
Can you say a little bit more about what you mean by the sensitivity of the instrument?
I mean, for working, some of these instruments are not very, in impact evaluation studies, what I've seen is that they are not very sensitive to intervention, just because they're not people that they don't really change much. Maybe, they are kind of threshold instruments where if you don't have a sufficiently strong intervention, basically you're not able to see any change.
Okay. So in other words, like for the Plato where we don't see this relationship, you're asking, could it just be that we don't see that much variation in Plato at all? Yeah, that's a good question. There are some differences in terms of how much variation you get in scores instrument to instrument. I believe that the class performs pretty well on that, and the UTOP perform pretty well, and the others perform less well, but there is variation in all of them. The points of the distribution differ a little bit by instrument. So, for example, many of the instruments do a better job at sort of distinguishing low scores and middle scores, and they have, less of the higher scores. But I don't think we've seen enough to suggest that, there's very little or no variation in one and not in the other. I think the other thing that's interesting is that we look at 4 different classroom composition measures. So the differences that you see across the 4 different measures in the results also begs a question of, suggests it's something about the actual classroom composition rather than just picking up relationships to anything.
We're done now, right? So on clarification, or should we?
We do have a brief, just a couple discussion points we want to make.
Do you have clarification?
I have a question.
Wait.
I have a question on this point,
Okay.
if I may.
Yeah.
Do any of these instruments have any way of finding out about the perceptions of teachers about these classrooms? Are they asked? Is there any? Is this a difficult class, or is this etc.?
Yeah, so I don't believe so, although I think the Plato may include some context questions, but I don't think they're from the perspective of the teacher. However, for anyone interested in getting access to the MET data actually, they also collected information from teachers on their perceptions of the school environment. So there is data that you could look at in order to kind of get at that question.
We just take clarification because you have 5 minutes more to your presentation.
Okay,
or?
yeah, I think that'll be okay. Yep.
Yeah. Okay. So do you want as well?
Yeah, just a quick question. Were you able to disaggregate the non-white population into Black, Hispanic, Asian American, etc.?
Yeah, we didn't look at that, and I don't remember for sure what the breakdowns were, but the reason that we didn't is because there were larger percentages of some groups than others, and we didn't want to exclude some of the groups. So essentially, we could have, for example, focused on African American versus white students, and then exclude, the other students. So we chose to keep it in the binary variable in order to maintain all the information.
Let's just do Dion and then get back to the presentation.
I'm just curious as to whether embedded in any of this is the characteristics of the teacher. So,
Yes.
for me, is the instrument sensitive to the characteristics of the teacher, not just the classroom?
Yeah, that's a good question. So no, the instruments themselves are not. In our study, if the randomization works in the way it's supposed to, that should control for any characteristics of teachers because the teachers are randomly assigned to be with a particular classroom group. However, there is some work, some recent work by Steinberg and I think Garrett also, that is looking specifically at this question about not only bias that might be due to classroom characteristics, but bias that would be related to teacher characteristics and the match between classroom and teacher characteristics. It's observational that they're data that they're looking at, but it gets at that underlying question. We appreciate all the questions. I'll just speed through a brief discussion. I'm going to talk just a few key implications for policy and practice, at least in the U.S., and then I'll pass it off to Audrey to talk about implications for international work. So one implication is for agencies and researchers who are trying to choose from among existing instruments. And our results that suggest that in order to select the observation instrument that best meets their needs, they should consider which instruments not only measure the dimensions that they want to prioritize, but perhaps more importantly, which ones maximize coverage of subdimensions within those dimensions, because that was the place where we really saw more of the variation, although there were some differences in the overall dimensions. Another implication is for times when observation scores that are more strongly related to student learning might be desired. And in those cases, our results suggest that researchers or agencies consider placing more weight on the classroom management scores than on other scores. However, when people do this, they should keep in mind that classroom management might just be easier to measure and observe, not necessarily that it matters more for student learning. So if you're looking for a measure related to student learning for research purposes, this may be less of a concern, but if you're using observation instruments for formative purposes, this is important to remember. And third, when concerned about potential bias in instruments, there's a couple things that you could consider doing. One is, if you're very worried about it, you could choose one of the instruments for which we didn't see scores being related to classroom characteristics. So for example, you might choose to use the Plato rather than the FFT or the class, or you might choose to focus on math instruction rather than English language arts instruction. But you also want to keep in mind that those effects we saw might represent real differences in teaching. Another option would be to target efforts to reduce the likelihood of rater bias toward the classroom environments where we saw bias to be potentially most susceptible, which was in English language arts instruction. So for example, when thinking about training and concerns about rater bias, you might spend extra time training observers to reliably apply standards to English language arts instruction, since our results suggest that there may be more cause for concern there. Okay, I will pass it on to Audrey.
Okay. I'm going to speak very quickly. We don't have any kind of a study that does what Megan and Brian's study did, looking at the international use of instruments. So I want to share mostly based on my own experience, and I've primarily worked with Stallings, as Rima said. I've also looked and used the class a couple times, but I have a lot less experience with class. But I want to just point out a couple of the similarities and differences, and then just maybe talk a little bit about some of the key implications that I think apply internationally that are slightly different from how classroom observations are used here in the United States. Oops, I need to do that, sorry. Okay, so in terms of similarities, I agree with Megan. I think internationally, there's just not a lot of information on which dimensions of instruction merit, the greatest emphasis right now. There are groups in international education. It's been, over the last decade, been very focused on reading and early grade reading. And so a lot of the research type observation instruments have really focused in on, the reading aspect of instruction. Is that or the time use in the classroom? And, when we look at like Stallings, for example, similar to class, it overlaps with some of the focus. You can use it to understand what the students are focusing on, what the teacher's focusing on, the extent that kids are participating in the class, their engagement with the teacher or engagement not with the teacher. I think what Stallings in particular adds that the other instruments don't is that it also looks at how teachers are using materials for the purpose of instruction. And then there is that time component. It also, I think, similar to some of the instruments Megan talked about, there's a high correlation with student learning scores and student characteristics, not just in language, but in all of the subjects, actually make a difference in the results that you see. But again, as it's correlated to student learning, different from, I think, what you were talking about, which is how teachers are rated using the instruments. Oops. So, a couple of the differences, I think internationally we've tended to use more low inference tools. So Stallings is a very low inference. It's with a 1 week intensive training program and practice, you can get very high inter-rater reliability, and it tends to be a much more objective rather than subjective instrument. So it's looking at time, and it's pretty hard for the observer to sort of bring in their own interpretation if they have that training and they've met the qualifications to be certified. I think internationally, it's different than domestic because here in the United States, I think teachers, generally speaking, are above 80% the use of time effectively. I think internationally, the question becomes, what do you look at? What dimensions? what do you really want to measure with these observation instruments? And this is just an example, and I'll just talk through the Mozambique. This was a study we did probably 8 or 9 years ago already, but it looks at the loss of time. It uses stallings for the last bar, and it pairs it with a series of other instruments. And so in Mozambique, you start with 183 days of official instruction. That's how many days the kids are supposed to get. When you deduct teacher absenteeism, student absenteeism, the time that's lost because the recess goes on for a half an hour instead of 15 minutes, the school not being open for random reasons, like the teachers weren't there, or there's elephant mating season, or some other we've encountered that. You see, and then you deduct, the class time. In Mozambique, the kids only get about 30 days of actual instruction. And so when you're talking about 30 days of actual instruction, then what do you go in and observe in terms of quality? So I think when you're considering these instruments, that component becomes really important. I think the other thing to understand is, again, this is for research purposes. I think in Barbara's study, there was a whole component looking at what supervisors and school directors do. And observing teachers was one of the things they spent the least amount of time on. And so I think here in the U.S., there's a very good structure where you have, district folks or school principals that actually observe and give their teachers feedback. In most developing countries, that system doesn't exist. And so the purpose of classroom observations becomes, I think, a little bit different. And I think that needs to be considered as, you're thinking about what do we really want to measure internationally. Sorry, go back. Sorry. And then just really quickly, so some of the implications, I think, again, this issue of dimensions, what is it you really want to measure and what makes sense to measure, I think is really important in these developing countries. What is the purpose of the observations? Again, as a researcher, understanding time on task, maybe understanding the quality of, how teachers are delivering reading instruction, for example, can be important, but rarely is that actually fed back to the teachers. I think if you're planning on giving that feedback or instilling a observation system like they did in Mexico, then the purpose shifts and maybe it's a different set of instruments. You also need to consider the language of instruction, cultural norms. A lot of these subjective instruments become very hard to convert internationally. And it requires you to have very highly trained enumerators that often have to understand local languages because often local languages are used in the classroom in order to really understand what the teacher is really doing and not misinterpret something that's happening. And so again, that, the objective versus the subjective, the high inference versus low inference becomes, I think, increasingly important in the international context, which is the last point. So I'll stop there. Again, this is a little bit different, in terms of how the instruments have been used than I think they are here, but at least some points to think about.
Thanks very much. I'm going to give it to you, Marjorie. I'm just looking at the time. I know we said 20 minutes, but if you can make it a little bit less, that would be great. But you have 20 minutes.
I prepped for 10.
Oh, even better. That's great.
It's a really fascinating paper, and there's so much you guys had to cover. So thank you. It was great to hear. So very quickly, I'll go over, I'm going to take a little liberty with your title and make it the content, potential bias, and predictive power of these 5 instruments. So very quickly, I'll go over content and predictive power. I think one of the things that you guys absolutely nailed is this idea of what is effective teaching. Domestically, there's so much talk about effective teachers, what is effective, what is teacher effectiveness, but the measures that are being used, they are with themselves within themselves so complex, and then when you start to put them side by side, I 100% agree that taking your own dimensions, extracting them from where the different measures are viewing them, makes much more sense, because if you think about it, in the MET study, the Plato element or domain of language discourse wasn't even used. But from the different parts of Plato, where you did have metadata, you can extract that. And so that tells you how much processes and practices in classrooms overlap. So you guys are one of the first most comprehensive analysis that I've seen. So let me go on to potential bias, and I think some colleagues here picked up on that as well. So I work on a classroom measure that is for international settings. And working in different contexts, the rater bias, or the assumption that the rater is picking up exactly even after being certified, it's like a tricky topic. We work a lot around tailoring the training in a way that we pick up the cultural contextual, the context that the culture imparts in the classroom. And so it would have been, I know the metadata has some information on reliability, but most of what I've read, they say, oh yeah, all raters met the standard. But within the standard, this is qualitative information that is being channeled through a person who is quantifying it. And so that rater becomes really central in the way that we understand what's going on in the classroom. And that's why I wanted to put potential bias first, because it's true that we have our own biases, whether or not we admit it. I train observers to not be biased, but sometimes when I see an undergrad and they're like, oh, I gotta go do this and this, I'm like, oh, you're gonna be a terrible rater, So it's bias is so hard to set aside, and people who are much more smarter than I have figured out approaches to deal with that. And one of the approaches, which I think is really useful for international work, is also conducting a generalizability study and then following it up with a decision study. So very briefly, a G study will take all the variance that is impacting the score that you're getting and parse it out. So one project, the Ruler out of Yale, they did a G study based on, so the Ruler is a social-emotional intervention, and so their G study was really, I think it's a really good example. So it wasn't just, the teacher effect, or someone here said, like the student characteristics. It was also what time of the day was this classroom observed? Teachers do different things in the morning versus like after lunch when everybody wants a nap. What time of the day, looking at, what time of the semester it is. So, and we've seen this in our work in Uganda as well. Like when semester starts, things are kind of hazy because teachers are taking it easy versus, when exams approach and then everybody's like, you must learn everything under the sun. And so, the timing of the semester, the timing of the, of the school day, all of those components add to that variance, but then they also add to measurement error. And so a G study is a really good way of looking at that. And you can follow it up with a decision study or a D study to, accurately or reasonably understand, okay, how many observers do I need? What is the best time of the day that I should go in? What is the best time of the semester that I should be observing for, say, more, instructional support, or to sort of understand how instructional support works in the classroom. So I think for the international context, that's also something important to look at. And then finally, and so that brings me back actually to your comment about the heterogeneity of the classroom. So it might just be that the teacher is I think ideally we would want to see that the teacher is responsible for most of the variance that we're seeing in our data, right? But it might be that, it's the time of the semester, or it might be that the students, as you guys looked at, non-white versus, free school, free lunch program eligible kids. So it might be that, and it's just with what I've learned with classroom observation measures, the devil literally is in the details, because in a classroom everything is happening all at once, and it sort of becomes our task to separate those out to then really get to this answer of, well, is this an effective teacher versus that person? And it depends a lot of the context in which that they are teaching.
And in some cases, they're not even in classrooms. In Mozambique, they were teaching under trees.
So
which also
classroom.
makes...
Exactly.
But it affects what you're seeing, how the kids are acting, what they're absorbing. So you have to look at that context. It's a much different situation than you face in a lot of other places.
Right.
In OECD countries.
Exactly. Which sometimes I feel like is an unfair comparison, but that's another discussion at the end of the day. But otherwise, I think this is such important information. Thank you all for presenting.
Okay. Thank you very much, Marjibin.
I
think. No, you did great.
Can I say a little bit more about this bias issue? Because it's clearly, it seems to be a pretty major interest here. And I guess I should say that, the beautiful thing about the random assignment is that it allows us to rule out some possible explanations for the correlation that you see in observational studies. So we don't have to worry about the possibility that the teachers of disadvantaged students are getting lower scores because they're actually worse teachers. We've got random assignment. We can rule that out. That said, it doesn't help us rule out some other alternative explanations, and that's one of the frustrations here we're sort of left with, is that we've still got at least theoretically possibilities that the remaining correlations we see are due to biased observation instruments, biased raters, which we sort of lump together with that, but that could be something conceptually distinct, or biased teachers. All of those could at least potentially produce those results. Now, that said, I think we do have enough information here to at least suggest that some of these explanations might be more likely than others. In particular, we know that the relationship to student characteristics doesn't show up on all the instruments. Some of them appear to be unbiased. And it's not just because they're all noise. So for example, we don't see any relationship to student outcomes on the Plato instrument. And the Plato instrument is also the one, as you heard, that has the broadest coverage of dimensions. As it turns out, in the prior research that the MET team, the original MET study team did themselves, the Plato had a slightly stronger correlation with student achievement outcomes as well. So it's producing even more differentiation without producing any bias. That kind of suggests to me that there may be some instrument-specific problems going on here. That if the problem was that the teachers were biased, then you might expect to see that show up even on these other instruments that do have differentiation and do predict student achievement outcomes.
So let's collect questions. I saw Dan, Alonzo, maybe 3 or 4, and then we'll collect more. Dan, Alonzo, Chiro, And then we stop there. And your name?
Maria.
Maria. Maria. We stop at Maria and then we continue in the next.
So my question is on the correlation with the student achievement. So I'm just wondering, so you use this observation score. So what is there any quantitative thing behind it? I mean, you're comparing the impact, the effect, marginal effect, right? So that's marginal effect of the increase of the score. But what does that mean? So the classroom management score increase 0.1. How does that compare with the other dimension that increase 1? I'm just wondering whether you're comparing the marginal effect, but you're trying to quantify something that is basically it's qualitative, the observational. I'm just whether there's a time use in the classroom, whether there are quantitative things behind the score. Then you can interpret the marginal effect. Actually, you can compare different dimensions.
So the instruments do attempt to quantify, but you're right that they attempt to quantify something that's fundamentally qualitative. So all of them include rating systems that do something like say, we're looking for classrooms that show supportive classroom environments. So we're looking for example, evidence of warmth and support in the classroom, absence of negativity, inclusiveness in the classroom, and they have all sorts of indicators the rater's supposed to look for. And the rater's job is to take what they're doing is looking at a classroom and making a qualitative assessment, as you're alluding to. Their job is to convert that into a quantitative number. And for each of these instruments, there are training programs that all the raters went through and certification processes. I think that Majaveen also referenced, all these instruments have been shown to have good inter-rater reliability, suggesting that there's some validity to the selection of a 1 versus a 2 versus a 3 versus a 4. But, as you point out, there are questions in what it actually means in reality, like how different is a 1 from a 2? How different is a 2 from a 3? And those may not be, linearly related. In our study, we are making that assumption to some extent, because essentially what we're doing is taking the scales as they exist, we standardize them. In some cases, we're combining them together for other measures. And, we're trying to get this quantitative measure that is fundamentally relying on raters to make a judgment, imprinting a quantitative scale on top of a qualitative judgment. I think that one of the things that is unique about this study, that we were excited about with the metadata, is when you're thinking about a given instrument and how much you should trust, the difference between a 1 and a 2 on the Plato, for example, you might have questions in your mind because we know of all these things that are going on that create measurement error. So even though there's overall, good inter-rater reliability and there's some validity and these instruments have all met, various measurement standards, we all still know there's going to be measurement error involved, particularly when you're trying to measure these high inference items, which it's difficult to assess even with a lot of training. Are people in this room intellectually engaged right now? I'm going to say yes.
I'm going to say 2.
You're going to say
I gave it a 2. I won't tell you what the scale is. But one of the advantages of this study is that for looking at the relationship to value added, we combined the measures from all these different tools. And the idea there is we were thinking this, in some sense, should give us, at least theoretically, the best possible measure, because we're using multiple sources of information, not only on a given score for a given instrument, but across different instruments, all of which have these rating systems and have met these levels. And so, at least theoretically, you would hope that what you're getting is a measure that means something. I do think the fundamental question that you're getting at, which is, at the end of the day, you say, okay, we move from this point to this point on that scale, what does that actually mean? Is a difficult one to answer. And certainly with correlations, it's even harder to sort of say, well, we know how they covary together. In some of our follow-up work, we're doing this in a regression framework so that, we can interpret it as an effect. But even there, we're running into this fundamental difficulty that we think, what makes sense to people? Do we talk about movement in standard deviations? You know, like, okay, if you move a quarter of a standard deviation in performance on this measure, it's associated with this on outcomes. And I think even that, you know, is, for people, it's like, well, what does that mean? You know, another option is to stay in the original scale and say, okay, well, about a 1 unit change on this scale is associated with this much improvement, but then people say the same thing. We're like, well, what does a 1 unit change mean? And we kind of get back to the same fundamental problem. But to me, it's a question about instruments themselves, and it's part of the reason for looking at their relationship to value added. You know, while we could have a discussion about the merits of a value added measure for assessing student learning, but the idea is, like, if we anchor those together, it gives us some sense of how they're related. So if you believe a value-added measure captures student learning to some extent, it's at least telling you something about, you know, what movement on the instrument means.
So Megan, what I'm going to do is actually collect a few, if you don't mind, and that way you can choose which ones to spend time on and which ones you can skip, just to get everybody else to get a chance. So let's go with, actually we have an online question, and then I'll go to Chiro, Alonso, and probably Maria, and then come back for another round. So until I say answer, let me collect some questions.
Sure. I'm going to read a question from Mirna Machuca Sierra, who's based in Tonga. In your analysis, are there any class size differences that show differences in the classrooms in your data? If there is, how did you control for that in your classroom composition analysis? From our project's classroom observations in the Pacific Islands, we can see that classroom size and multi-grade, more than one grade in the same classroom with the same teacher, have a significant impact on teacher classroom strategies and decisions over content.
Great, thank you. So we have that. Now we go to Chiro and then Alonso.
The question is about, you know, the fact that you find a stronger correlation with the classroom management compared to other dimensions. And the concern is that you are the stronger correlation is just driven by the fact that you have a smaller measurement error in that dimension compared to others. I was wondering why, since you have, I understand that you combine different instruments, but that does not solve the measurement error. Would sometimes actually make it worse. I was wondering, why don't you try something in the style that Heckman does with these latent factor models, where basically, since you have a multiple measurement of a single dimension, that would allow to overcome the measurement error.
Great. So we have Alonso next, and then Maria.
Mike, so I have two questions very quickly. This issue of the classroom management dimension being the one most correlated to teacher value add, that's an average of all the instruments, correct? So if your first policy recommendation is to think of the instrument that works best for you, shouldn't then you look down and see which instrument of that, which instrument that you've selected, and look at the dimensions that matter and that are correlated with value added? I mean, so I'm just thinking about, it's more of a decision tree than a simple sort of, it all kind of links, right? And so that's one question, kind of comment. And the other one is something related to what Audrey was saying, which is in your deep analysis of the instruments, is there one of them, or are there characteristics of them that make them easier to be taught, to be able to rate effectively? Is the Plato perhaps, the one that has all these really great characteristics, but takes 3-4 weeks to bring everyone up to speed on it, versus, another one that only, takes 2 weeks or less,
Maria?
Okay, so I have mostly worked in Pakistan. I was working on creating a rubric for schools in Punjab. So this was like really relevant to the work that I've been trying to do. My question was that for in a developing country context, we were trying to include indicators which were very basic. So I've looked at the indicators that were part of these rubrics, but then we were trying to maybe include things like did the teacher had the lesson planned? Were they prepared to deliver the classes? Did they check the written material or not? So I was just wondering if in your research did you come across any rubrics that were used in developing countries, and how so if different countries are at different stages of development, how do you, when you compare countries, how do you look into take into account the different rubrics, and how do you do a case by case analysis given that different countries have different growth trajectories and different conditions? And the second thing was that were any development areas assigned at the end of these ratings? So the teachers were marked on like 6, 7 or whatever indicators, but at the end were they assigned any development areas based on the rankings on different indicators? And did you see any positive or negative effect for that?
Great. So let's now I'm going to give you to answer, starting with the Toga, or in any order you want. You have 4 questions. One on class size. You've got them, I guess.
Does anybody have a preference? Anyone have a preference of where to start?
Take your pick.
Okay, well, I'll start in order that we received them then. So the class size differences, this is a great question. This is not something that we looked at in this study. It is an astute question because, as we discussed earlier, the classroom groups were formed non-randomly, and then teachers were assigned to those classroom groups. So the classrooms could differ in classroom size. We have looked, and we do see there is some variation in classroom size from between the classrooms in a randomization block. We didn't control for that in our study, as I said. A couple things that make us a little less concerned by that. One is that there is a sort of parallel study that's been done by Steinberg that looked only at the FFT instrument, but also was looking at this question of bias, of relationship between observation scores and student characteristics. They focused specifically on the average achievement levels of a class from the prior year. And in their study, they do control for various factors, including class size, and they use all kinds of different methods to identify that. And basically, their results hold up, and they're using the MET data as well. The patterns hold up even when controlling for class size. The other thing is this specific mention of multi-grade classrooms. In the MET project, all of the teachers were teaching single grades, so each was assigned to a specific grade. So we at least don't have that issue of sort of fundamental differences in what the classroom environment means by combining them.
Yeah, another thing to say about that is that class size might well matter quite a lot in other contexts, but in this particular study, the fact that the randomization is within schools means there's not going to be nearly as much variation in class size as there would be sort of out in the world across schools or across countries especially.
Internationally, again, this isn't related to the MET study, but the other work that we've done, class size has been important. But only once it gets up into the 40, 50, 60, 120 range. So I think when you have class sizes that are small, up to 30 kids, you don't see a lot of, variation in a particular country. But, when you compare like a Guatemala, where the class sizes tend to be, similar to the U.S., to like Haiti, where we had 120 first graders in a class, and even with 3 teachers, that has a significant impact on the teacher's ability to actually be effective, no matter how you define teacher effectiveness. So internationally, the class size, I think, does make a difference. And a lot of the studies that we've done have looked at that. I think Barbara looked at that as well and found similar. I can't remember, but...
Great. So some of the other questions? Did you...
So there were a couple on classroom management. So first, Chiro's question. this is a great suggestion. We're already moving on to it. In our follow-up work, that's one of the things that we're doing. We're actually using a factor model in order to essentially control for the differences in the measurement error. Because as you point out, even though we combine things in an effort to reduce the measurement error, but you also pointed out that doesn't necessarily work, there still could be differences in the amount of measurement error between the two dimensions. So we do move on to the factor model, and I don't think that I can talk about the results yet, so you'll just have to stay tuned for that.
No, we just want to avoid that everyone is running out and just making programs that work on classroom management.
Right.
This is the concern.
Yes, absolutely. And I think it's a really important point to make, because this was probably our first reaction. In our second reaction was thinking like, okay, there is theory to suggest there might be reasons why classroom management is foundational, but our first reaction was this concern of, well, how much of this is due to the measures? So I think the safest interpretation is to remember that our analysis is telling you something about the measures as they exist and not something about the practices themselves. Okay, the other classroom management question.
The decision tree.
Oh, the decision tree. Do you want to speak to that?
Sure. So it's a good point. I mean, I think your question speaks to the fact that we've got multiple purposes in this research. But if you were actually choosing a rubric, you'd want to pick the rubric first and then confirm that which dimension is most strongly related. I think that from a research perspective, we thought it would also be interesting, independently of individual rubrics, to see across the rubrics what dimensions most strongly predict.
Does your paper have the correlations between the dimensions and teacher value added by instrument?
We do. So when we looked at the consistency of the relationships, that's what we did. Yeah. I don't think that our appendix reports the actual correlation coefficients. We report summary information. And I can't remember for sure, but I think that when we looked at it, when you look by instrument, it's not perfect, but in general, it does follow the same sort of trend. So, for us, the takeaway was sort of, the consistency question was getting at, well, what happens if you're just thinking about these individual instruments?
And then I think the rubric question for developing countries, maybe I can take that one.
Go ahead, sure.
So all of the work that I've done where we've gone in and it's research-based, we've always had a cover sheet that collects, the types of information that you're looking for. It's varied by country. Sometimes we're looking at, does the teacher have this? Does, she do this? Check, check, check. You've got sort of a checklist in addition to the actual observation. And those can be adapted depending on, what you're looking for. RTI and under the Ed Data 2 project, they also developed a school management tool that's a checklist that that you could use. And they have some more instruments that, get at that. But again, often they were done as, cover pages or through teacher interview protocols. So I think in most of the studies, they've been multiple instruments paired together to get a more holistic sense of what's happening, again, because the purpose was research.
And then on your question about the feedback to teachers, in this study there wasn't any feedback to teachers. It was sort of purely about the instruments. It wasn't part of their formal evaluation process. And it's a great question. And in fact, there's a good bit of research going on now to try to examine whether feedback based on instruments like these actually produces improvements in outcomes. There have been some non-experimental studies that have suggested promise. Taylor and Tyler did one in Cincinnati suggesting that going through an evaluation process improved teacher performance afterwards. I think AIR is doing a randomized study right now that's actually going to provide experimental evidence, but they haven't gotten to outcomes yet. So it'll be interesting to see more of that.
Yeah, we have that in Punjab, and it has worked well for us in terms of improvement in teachers, but hasn't really translated in student outcomes.
Because it takes time.
So I'm looking at the time, and I did want to take a second round, but it looks like we will need to stop. And I hesitate to say, can you stay and ask more questions? I know Alonso's like, you didn't answer my second question, but
Yeah, exactly.
that was my choice, I'm sure.
Where some of the rubrics easier to score than others, or easier to train on.
The
right.
inference question.
Yeah, we don't know the answer to that.
I mean, you didn't develop instruments and had to train, so
Yeah.
you don't have that experience.
Yeah.
But but what is your name? I'm sorry,
Majabi.
Maybe you can say something about that.
I was going to say these measures, the content-specific ones, the math ones, you really need to understand what's going on in a math classroom to actually evaluate or observe the classroom. The more general ones, like the class, the FFT, and Plato is a little more focused on instruction as well, but Plato as well, they all have a really similar training structure in the sense that what they want is that observers should be really clear about the behavioral indicators that they're looking at in the classroom and how those contribute to the different domains outlined by the instrument. So if you're not familiar with basic classroom processes, I would say it's tough. But then it depends by instruments. Some of them are more general and a little more, I hesitate to say this, subjective, whereas others are very specific and classes like domains and dimensions and then sub-dimensions and then behavioral indicators and so it depends, but they all are technical in the sense that you at the end of the training you leave understanding how to understand the classroom that you'll be looking at.
Yeah, my experience between internationally with class and Stallings, which are the two that I've personally done, is class was much harder to get to that inter-rater reliability, whereas Stallings, I think because it's a little bit more general and it's very time-focused, was easier to just get everybody on the same page.
I would add here that the tricky part is contextualizing to the context, which is why one of the things we do is we insist on having local observers who have, this instinct about local classrooms, which also means they have biases, but they have an instinct about the classroom that they are going to observe. So you shouldn't put me in, like a Mozambique classroom. But
definitely not on
the we've worked.
Yes, definitely not.
We've always worked with local enumerators. It has varied based on our pilot testing, whether we've used folks that are familiar with the education system or more research type folks, because again, they bring in the bias, or they want to, if they're former teachers, they want to correct what the teacher's doing in the classroom, which, is still addressed in the training, but I think my experience has been a little bit different in every country. But we've always also worked with local enumerators. They've always done all of the data collection.
So I want to now say a huge thank you to all four of you for really, for the 2 hours and for flying from all over the place. You're in Washington? No, you're in New York.
New York. I
took
the train.
Yeah, you took the train. Well, so taking the train or flying from all over the place, for being with us for 2 hours, for patiently listening to our questions and trying to answer them. And we look forward to staying in touch. This is exciting work. We're all trying to figure out how to do it, right? So we will stay tuned for all the things we promised to as is coming. And thank you again very, very much.